Today we are going to be looking at acid nomenclature. Acid names are often given from the transformation of whatever its ionic name would be. So if the ionic compounds ended with an IDE suffix, that would be becoming hydro, whatever that substance is, ic, acid. So if we had the substance H3N, and it was aqueous, its ionic name would be hydrogen nitride. To make it into its acidic name, because it ends with the IDE suffix, it would become hydronitric acid. So the nitride would stay for the hydronitric acid. So nitride, nitric, same lettering. Another example using that same IDE suffix would be something like HAT, aqueous. That ionic name would be hydrogen acetate, which would become hydroacetic acid. So that acetic and acetate would be the same lettering. The second type of ionic compounds can have the ATE suffix. This usually comes from your polyatomics. Now that ATE suffix would become whatever that substance is, ic acid. So notice that it drops the hydro. There is no hydro anymore. So if, for example, if we had H3PO4 aqueous, that would become, in its ionic form, hydrogen phosphate. For its acidic name, it would be phosphoric acid. So that phos and phos on both sides. Another example would come from the HNO3 aqueous. Its ionic name being hydrogen nitrate, which becomes nitric acid. Same NITR, NITR. Just drops the 8 for an ic. We can actually go in reverse now as well. So given the example, oxalic acid, well, knowing that it doesn't have the hydro in front of the oxalic, that tells us that it's oxalate as the ion. So because it's an acid, it has to have hydrogen in our cases, so that will be hydrogen oxalate. Once we know that it's hydrogen oxalate, well, going from an ionic name to its formula is very simple. We'll have that oxalate ion with a 2 minus, and we'll need 2 hydrogen pluses to balance that out. The last one we need to learn is the suffix ITE. Again, this will come from your polyatomic table. The ITE suffix will become whatever that substance is, OS acid. So given the example HNO3, that's, as its ionic name, hydrogen nitrite, which will become nitrous acid. So the ITE drops out and is replaced with OUS, OS. So nitrous acid. Just like the previous one, we can go backwards now. So if we were given sulfurous acid, we would know that as with that orous acid, we know it doesn't have the hydro in front, so it's going to be ite, because OS becomes ite. So we have sulfite. Because it's an acid, it has to have hydrogen attached to it as well, so that'll be hydrogen sulfite. And going from hydrogen sulfite to its chemical formula, well, we have the sulfite ion, SO3, which will be 2 minus, and we will have two H's that will need to be used to balance those out. Now, there is some funny sayings that kind of help you to remember them, or at least they helped me remember them as I was learning these. For the first one, where you have something "ide" becomes hydro something ic acid, I learned that you hide a hickey. So hide, Hide, so that hydrogen something "ide" becomes hickey, so H hydro something ic acid. It's kind of silly, I know, but bear with me. It does work. It does help you remember them. For our ate suffix, we can remember ate something icky, like you ate something that was icky. So didn't taste very good. So the ate suffix becomes ick. The last one is bite something delicious. So you get that ite becomes ous. They may help you, they may not, but they're there for you to try and memorize them well. Now what you guys can do is work on the assignment from yesterday, giving those ones where it asks you to name the acids, and they'll be passing around a worksheet that has just nomenclature on them. Good luck.